Hello and welcome to the last video of this series describing the banking application I have developed. Bank is a simple-based web application developed with the MERN stack. In this video, I will show you Bank in action. A React-based front-end connects to a Firebase application to handle users. No passwords are sent to the backend, as authentication with the backend is performed through JSON Web Token. All data related to transactions and bank account details are stored in a cloud-based non-relational database. At the landing page, we have the option to log in or create a new account. Everything else is reserved for authenticated users. There are two options for creating accounts: either create an account with email and password or using Google credentials. Once the user is created, the account is set up. As it can be seen, the changes are immediately reflected at the backend and in Firebase in case of the new users. All transactions are made through forms created with Formic, so validation is done at the front-end level to ensure only valid transactions are sent to the backend. I use also Suite Alert to have more visually appealing and easier to program pop-up alerts. Once the user has been authenticated, the main page shows an account summary from where the user can go and perform different transactions, such as deposit, withdrawals, or even transfer. There is a summary page showing the historic transactions that are recorded in backend. The database has a single collection called users, and each user is a document of that scheme. Each user is identified by a unique email, which is checked during account creation. A user document also contains two arrays, one to store account details such as the number and potentially the type of the account, although at this first version only one type of account is considered. And the history array, which is the main collection where the transactions are stored containing the parameters that defines the type of transaction and the amount. Always a positive number, because the type of transaction defines whether to sum or subtract that from the current balance. It is important to note that the balance is updated at the front end, and any new transaction contains a balance element which corresponds to the balance after the transaction. The balance from the last transaction is the current balance displayed at the front. For deployment, I use Render, which is very simple to set up, similar to Heroku, and allows continuous integration and deployment from a GitHub repository. As you can see, just following the instructions, I could replicate what I had in the local repository, separating the two entities, the backend and the front end, and just updating from the configuration files, putting the values in the variables required, the deployment was done. The good thing is that because it's a continuous deployment, every time I do a push into the GitHub repository, it triggers a redeployment of the backend or the front end, depending on where in the folder was the update. I've added a few additional features to make the user experience more realistic and closer to a real banking application. Once the user is logged in, on the upper right corner, the name, email, and current date are displayed. These values are taken from the Firebase, so if the connection with the backend is lost, they will still be there. I also auto-assign an account number based on the timestamp of creation, so I ensure a unique number is assigned. This is done at the middleware functions closer to the backend, so it is not possible to alter that from the front end. The ability to download transactions as an Excel file was implemented using an NPM module which does exactly that, similar to what I did for the language selection, where I used a Google Translation API. Although it's not perfect, but it's a very good starting point if you want to have a multi-language website. For functionalities that are present in the routes, which are in the backlog, for example, but are not yet implemented, I've added an additional component to redirect these calls. Also, note the loading spinner at the top, which is useful to indicate that the system is waiting for something to happen, based, for example, on the value of a state variable or process. A timeout session was included in case a user forgets to log out. In this first version, it is based on a fixed timer, 15 minutes, but for future versions, I will consider inactivity time before closing the session. Finally, I enabled the option to transfer between accounts. By retrieving the list of emails, a user can select one to transfer out. The data abstraction layer is responsible to record the transfer between the two users. As you can see in the database, it is reflected as a transfer in for the one that received the money, and as a transfer out for the one that send the money. One of the main challenges I faced was how to configure access to the endpoints and communicate in the backend with the front end. Although I have done that when following the lessons, but doing it in a production level environment, such as with Create React App and cloud-based authenticating services, has their own complexities that require further studies. For most of the debugging activities, I followed a local versus deploy solution and made use of console log everywhere. Looking back though, something I will definitely include in the process is integrating unit testing from the beginning and throughout the whole development cycle. It is not only a good practice, but will have helped me to visualize more easily the whole architecture and interaction between components. Thanks for your attention.